How far have humans actually reached in space? We've sent spacecraft beyond the planets. We've walked on the moon. But compared to the size of the universe, how far have we really gone? The answer is much smaller than you might expect. Let's start close to home. The boundary of space is often defined as about 100 kilometers above Earth. This is known as the Kármán line. Above this point, the atmosphere becomes too thin for aircraft to fly normally. The farthest distance humans have physically traveled is the Moon, about 384,000 kilometers away. Humans first reached it in 1969, during the Apollo 11 mission, and to this day, no human has traveled farther than that. Most human activity in space happens much closer to Earth. Satellites orbit between a few hundred kilometers to about 36,000 kilometers geostationary orbit. Even the International Space Station orbits at only about 400 kilometers above Earth. The farthest human-made object is Voyager 1, launched in 1977. It is now more than 24 billion kilometers from Earth, and still moving. Voyager 1 has left the heliosphere and entered interstellar space. This means it has moved beyond the Sun's influence, but it is still inside our galaxy, the Milky Way. Now here's the reality. The nearest star is over 4 light-years away. That's about 40 trillion kilometers. Voyager 1 would take tens of thousands of years. To get there, the observable universe is about 93 billion light-years across. Compared to that, even Voyager 1 has barely left our cosmic neighborhood. So how far have humans actually reached in space? The answer is heavy checkmark humans the Moon. Heavy checkmark machines deep space. But in the scale of the universe, we have only just begun. Everything we've ever done in space, all missions, all spacecraft, have taken place in a tiny fraction of the universe. And yet, even that small step has changed how we understand everything. Getting to space is only the first step. Leaving Earth's gravity requires enormous energy. Rockets must reach what is known as escape velocity. For Earth, that is about 11.2 kilometers per second. Without reaching this speed, a spacecraft cannot break free. This is why most missions stay in orbit. So why haven't humans traveled beyond the Moon? The answer is not just distance, it's time and resources. A mission to Mars takes several months. A mission beyond that would take years, and humans require oxygen, water, food, protection from radiation. Keeping people alive in deep space is extremely difficult. To this day, the farthest humans have traveled remains the Moon. During the Apollo missions, astronauts traveled about 384,000 kilometers from Earth. No human mission since then has gone farther to explore deeper space. We rely on robotic spacecraft. They do not need oxygen, or food, or protection from radiation. This allows them to travel much farther. Even robotic missions take years. For example, it took about 6 years for Voyager 1 to reach Saturn. Missions to the outer planets often take decades to plan and complete. Space is not just far, it is slow to cross. Here's where things become difficult to imagine. In space, we don't usually measure distance in kilometers. We use something called a light year. A light year is the distance light travels. In 1 year, light moves at about 300,000 kilometers per second. That means, in 1 year, it travels about 9.46 trillion kilometers. The closest star to Earth, after the Sun, is Proxima Centauri. It is about 4.24 light-years away. That is more than 40 trillion kilometers. Voyager 1, the fastest spacecraft we have, would take tens of thousands of years to reach that star, and it is not even heading in that direction. Voyager 1, the fastest spacecraft we have, would take tens of thousands of years to reach that star, and it is not even heading in that direction. When we ask, how far have humans reached in space? The honest answer is, not very far. At least, not yet. But every mission, every spacecraft, every signal sent back to Earth is a step forward, and one day, That distance may grow far beyond anything we can imagine today. Even inside our solar system, distance is only one challenge. Radiation in space is another major limit. Away from Earth, astronauts are exposed to cosmic radiation. Earth's magnetic field normally protects us, but beyond low Earth orbit, that protection becomes much weaker. Over long periods, this radiation can damage human cells and increase the risk of serious health effects. Another challenge is navigation. On Earth, we rely on satellites and GPS, but in deep space, there is no such system. Spacecraft must rely on onboard instruments, signals from Earth, and precise calculations. Even a small error can send a spacecraft far off course, over long distances. To communicate with distant spacecraft, scientists use something called the Deep Space Network. This is a system of large radio antennas, located in different parts of the world. These antennas send and receive signals from spacecraft billions of kilometers away. Without this system, we would lose contact completely. One of the biggest limits in space travel is speed. Nothing can travel faster than the speed of light, and current spacecraft move much slower than that. Voyager 1 travels at about 17 kilometers per second. That may sound fast, but compared to the distances in space, it is extremely slow. Another surprising fact is how empty space really is. Even inside our solar system, planets are separated by vast distances, and beyond the solar system, stars are even farther apart. This means that even when traveling for years, spacecraft often encounter very little. Time becomes as important as distance. A journey that takes decades requires systems that can survive for decades. Voyager 1 has been operating for more than 40 years. This is one of the reasons why robotic missions are so important. They can travel farther than human missions. Even our galaxy, the Milky Way, is enormous. It is about 100,000 light years across. That means even traveling at the speed of light, it would take 100,000 years to cross it. So when we ask how far humans have reached in space, we are really asking how far we have moved within an almost unimaginable scale, from Earth to the Moon to the edge of the solar system. These are incredible achievements, but compared to the size of the galaxy and the universe, they are only the beginning. Even if humans haven't traveled far physically, our signals have traveled much farther. Radio signals from Earth have been spreading into space for over 100 years. That means there is now a sphere of human-made signals, over 100 light-years wide, expanding in every direction. In simple terms, any civilization within that distance could potentially detect our signals. But as the signals travel, they become weaker and harder to detect. So even though our signals have gone far, they are not easy to find. So we have two kinds of reach. Heavy checkmark physical objects, like Voyager 1. Heavy checkmark signals spreading much farther. Voyager 1 is still the farthest object we've built, but our presence has extended much farther through radio waves. Reaching another star, with current technology, would take tens of thousands of years. Even the fastest spacecraft are far too slow. This is why scientists are researching advanced propulsion, new materials, long-duration space travel. But today, interstellar travel remains beyond our reach. Despite these limits, we continue to explore. Each spacecraft, each signal, each discovery moves us forward, even if the distance traveled seems small. So how far have humans actually reached in space? The answer is both impressive and humbling. We have reached the Moon, sent machines beyond the planets, and placed a spacecraft into interstellar space. But compared to the size of the universe, we have barely begun, and everything we have ever done in space still exists within a tiny fraction of what is out there. And yet, even that small step has changed everything we know about our place in the universe.